Every software vendor is converging on MCP as the standard for tool connectivity, and who can blame them? Here's an ecosystem that legitimately allows these vendors to extend their offering to places they've never had access to before. No shade. However, what nobody seems to be talking about is that every MCP server you add makes your AI system a little dumber. And that doesn't matter whether the MCP server is local or remote. The damage is done. Welcome to the Enduring Advantage podcast. I'm your host, Zachary Alexander. Look, I need to start by saying what you're hearing about MCP server and protocol are real. This isn't vaporware. This isn't another protocol that's going to die in committee or be forgotten before the beginning of next quarter. Anthropic open sourced MCP in November 2024 so that their competitors wouldn't feel like Anthropic had control of their futures. And it worked. By March 2025, OpenAI adopted it. Sam Altman's words were simple. People love MCP, and we're excited to add support across products. Then Google DeepMind confirmed support for Gemini. Then Microsoft integrated it into Windows 11, Copilot, and Azure. Anthropic made them all an offer they couldn't refuse. Adopt the standard or cede the integration layer. By December 2025, Anthropic donated MCP to the Linux Foundation's Agentic AI Foundation. Co-founded by Anthropic, OpenAI, Block, Google, Microsoft, AWS, Cloudflare, and Bloomberg backing it. Think about that for a second. Anthropic, OpenAI, Google, and Microsoft, companies that compete on everything, all converged on the same protocol in under 12 months. You'd be hard-pressed to find another technology standard that achieved this kind of cross-vendor adoption this fast. OAuth took 4 years. OpenAI took 5 years. Application program interfaces used to be the best way to programmatically work with third-party apps. Obviously, MCP is the replacement. Now, there's a lot that goes into that statement, but let's just save that for another podcast on the future of computer interfaces. Now, who can really blame all the vendors for coalescing around the thing? Here's an ecosystem that legitimately allows these vendors to extend their offerings to places they've never had access to before. Every major software vendor sees the same thing, a universal standard for connecting AI to everything. The right once, integrate everywhere promise that the industry has been chasing for decades. No shade. This is a genuine infrastructure shift, the kind that rewrites how systems talk to each other. But infrastructure shifts are still governed by physics. And when adoption is driven by competitive pressure rather than considered architecture, the physics catch up fast. So here's where the commentators get it wrong. Everybody's talking about MCP servers. How many servers do you have connected to your agent? Has your competitor released remote MCP servers, or are they still using standard I/O, which is local resources? Servers are the unit of measure in every article, every conference talk, every vendor pitch. Server count is a vanity metric. The real number that matters is tool count. When you connect an MCP server to your agent, the LLM doesn't just learn there's a server over there. Every tool that server exposes is loaded into the context window. Its name, its description, its parameters, its schema. That's the menu the LLM has to read before it can do anything. And here's the part that catches teams off guard. A single MCP server can expose somewhere between 17 and 50 tools. One server connected to your GitHub repository might expose tools for creating issues, managing pull requests, listing repos, handling branches, managing labels, and on and on. One server, dozens of tools. As a middle market CEO, you think you're being conservative and allowing things to play out. Because why would you and your team want to push the envelope? Say you've got 5 MCP servers, maybe a CRM MCP server, a file system MCP server, a database MCP server, a communications platform MCP server, and something for project management. 5 servers sounds manageable, except those 5 servers might be pushing 80 to 100 to 150 tools descriptions into the context window on every single call. Your operators at level 300 and above are already maxing out this window. Cursor hard capped their tool limit at 40, regardless of how many servers you connect. That's not a design choice, that's an admission. Developers on GitHub are reporting that performance starts to degrade noticeably around 50 tools. Over 80, and one developer said there were reported issues. Claude just shipped a feature called MCP tool search that lazy loads tool descriptions instead of dumping them all into the context window at session startup. Because with 7 or more servers, users were losing 50 to 70% of their context window before they'd even typed a prompt. Let me say that again. 50 to 70% of AI's working memory consumed by tool descriptions before you ask it anything. That's not a scaling problem you see on the vendor's pitch deck. That's the physics catching up. Now here's where things go sideways, and I don't mean gradually. I mean like floors collapsing under a great weight. The tool count problem I just described, that's just a snapshot. It's what your system looks like today. But MCP, Model Context Protocol, has more surface area that most vendors aren't even considering implementing. Tools are just one primitive. The protocol also defines resources, prompts, and sampling flow, where servers can request the LLM to do work on its behalf. And we haven't even gotten to roots and elicitation primitives. They deserve a podcast episode of their own. You may think, that doesn't sound like a bad thing. It is. It means that your current tool count is the floor, not the ceiling. As vendors mature their implementations, and they will, because that's how competitive markets work, each server's context footprint will grow. The CRM MCP server that ships with 20 tools today could expose 40 next quarter when the vendor implements resource subscriptions. Your database MCP server could double its context cost when it adds sampling, and you will not have deployed anything new. You will not have made a decision to shrink your context window. A vendor pushed an update and your context window got smaller, noticeably smaller. But the third-party vendors aren't your only exposure. In past episodes, we've talked at length about the benefits of custom internal MCP servers. We've suggested you think of them as IT silo busters. You and your team could decide to implement more of the MCP protocol within your organization. Building custom internal MCP servers, providing better service to your users, richer tool descriptions, more complete schemas, sampling flows that let your servers orchestrate work autonomously. All good engineering decisions, all providing genuine value, and every single one exacerbating the problem. This is the part that nobody is telling you. Competence accelerates the problem. The teams doing MCP right, using the protocol's primitives, they are the ones that will eat up the context windows fastest. The work slop that passes for most third-party vendors' MCP servers will allow you to push this problem off for a while. It could cost you your competitive positioning and the company's future. There's always a price to be paid for tech trade-offs. On the other hand, the problem exists whether you and your team create custom internal MCP servers or not. It could just as easily spike because one of your vendors generates buzz using one of the seldom implemented core primitives. But if you build internally, and you should, understand that you're accelerating a cost that nobody's giving you the tools to monitor. Then there's also what Scott McNealy said when he was running Sun Microsystem that stuck with me. Every middle market CEO should already know this in their bones. You got to find interesting things for good people to do, or you lose them. The MCP protocol is full of under-implemented primitives, resources, prompts, sampling, routes, elicitation. These are all frontier capabilities that most vendors haven't even touched yet. For a skilled engineer on your team, that's not a risk, that's a brand new opportunity space. And it's your job to find brand new opportunity spaces for people. You don't want to saddle them with nothing but maintenance. You want your best people exploring. You want them pushing the edges of what's possible within your infrastructure. That curiosity is the reason you hired them. It's the reason they stayed. The moment you tell an engineer that's off limit, it's the moment they start looking for another job. So here's the scenario. It's a lazy Tuesday afternoon in the middle of a quarter when things are running relatively smoothly. One of your best engineers reads a blog post about MCP sampling, or watches a conference talk on YouTube, or sees someone demo it on X, or LinkedIn, or Instagram. They get excited, legitimately excited, because they see how sampling could enhance the workings of your internal MCP servers and a way of providing capabilities that the senior management team has been asking for forever. They spin it up. It works. They share it on Slack. The team's impressed. Maybe someone else builds on it. Nobody notices that your system's context window just shrank 30%. No architecture review caught it because it didn't look like a deployment decision. It looked like a developer experimenting. No capacity planning flagged it because nobody's tracking average context cost per tool. No change management process was triggered because nothing was deployed in the traditional sense. An engineer got excited about a protocol primitive and your AI got measurably dumber. And it's not just that nobody caught it, it's that everyone incentivized it. The senior management team asked for the capability. The engineer delivered it. The Slack channel celebrated it. The entire organizational reward system pointed toward the thing that caused the problem. This isn't a process failure. This is a management paradox. Scott McNeely understood it. The cost of board talent is higher than almost any operational risk because it results in the need for new operators, new engineers, new people. You can't govern your way out of this because governance kills the thing that makes your team worth having. You can't tell your best engineers to stop exploring. You can't put a review gate on curiosity, or the productivity of your whole department will decrease. The only resolution is architectural. You need a layer that lets your engineers explore freely while managing the context consequences automatically. Something that monitors what's entering the context window, knows which servers are relevant to which task, and keeps your AI focused regardless on how many primitives your teams has implemented. Without that layer, you're choosing between two losses. Lose your engineers to boredom or lose your AI's effectiveness to their ambitious competitors. That's not a choice any middle market CEO should have to make. So what's actually happening to your AI when all of this is accumulating? There's a term for it. I think it's the most important concept in the entire episode. Context rot. Context rot happens when information about the surrounding situation, prior events, and current state that lets an agent assign meaning and choose appropriate actions degrade. And I need you to understand, this is not a storage problem. Your context window isn't a hard drive that fills up. It's the AI's ability to focus. And focus is a zero-sum game. When you add something, you got to give up something else. That something is clarity. Every tool description sitting in your context window is competing for attention against the thing you actually ask the AI to do. Your prompt, your data, your question. The stuff that matters. When 150 descriptions are loaded into the window, the LLM doesn't just have less room, it has less clarity. It's trying to reason about your business question while simultaneously holding the complete menu of every tool it could theoretically invoke. That's not a computer running out of disk space. That's a person trying to think in a room where 150 people are talking at once. Think about what would happen if you were to hand someone a filing cabinet and say, the answer is in here somewhere, figure it out, versus handing them the 3 documents they need. The person is equally capable in both scenarios, same brain, same expertise. But in one, they're spending most of their effort on retrieval and relevance filtering. In the other, they're spending it on the actual reasoning. That's context rot. Your AI isn't getting dumber. It's getting more distracted, and distraction compounds. As more tool descriptions enter the context window, the signal-to-noise ratio degrades. The AI starts making worse tool selections, choosing the wrong server for the task, misinterpreting parameters, generating responses that are plausible but not precise. Not because the model is bad, because the model is drowning in menu options instead of focusing on your problem. And here's the part that should concern every middle market CEO in the audience. Context rot is silent. There's no error, there's no alert, no dashboard turning red. Your AI system just gets gradually and perceptibly less effective. The outputs are still formatted correctly for the most part. They still sound confident. They just are slightly less right than they were before the degradation, and slightly less right than the month before. You won't notice it until someone asks why the AI's recommendations aren't landing the way they used to. By then, the rot has been compounding for months. Now, the obvious response to the thing I've just described is better search, better retrieval, smarter tool selection. Just use AI to pick the right tools before loading them into the context window. That's the intuitive answer. It's the kind of thing senior managers say as they pose for a mic drop moment when heading out the door. And it's where most of the industry is headed. Claude Code's MCP tool search does exactly this. It builds a lightweight index and tries to load only relevant tools on demand. And it's a genuine improvement over dumping everything in at once. But it doesn't solve the problem. It manages the symptom. And the reason it can't solve the problem comes down to how search actually works programmatically. Most AI retrieval systems, including the ones selecting which tools to load, rely on vector embeddings. They convert tool descriptions into numerical coordinates in high-dimensional space. Think of high-dimensional space as characteristics. 2 dimensions would be like plotting something by cost and speed. 3 dimensions would add a third characteristic, maybe reliability. With this information, you increase the precision of your search. Similar things end up close together, dissimilar things end up far apart. When your system needs to decide which tools are relevant to ask, it converts your task into a vector and it asks, what's closest? That sounds elegant. And for simple cases, it works. However, there is a well-documented mathematical problem called the curse of dimensionality, which states, as the number of dimensions increases, characteristics, the distance between all points converge. Everything becomes roughly equidistant, the same distance from everything else. And for the record, modern vector embeddings use hundreds of thousands of dimensions. Think about what that means for tool selection. Your retrieval system is supposed to say these 3 tools are relevant, those 40 aren't. But in high-dimensional space, the difference between your 3rd most relevant tool and your 40th most relevant tool shrinks to statistical noise. The system can't confidently say this, not that, so it hedges. It loads more tools than is necessary because the math can't tell them apart. The very mechanism that's supposed to create precision, more dimensions, more nuance, gradually undermines the distance matrix that makes recommendations work. You end up with retrieval that's approximately rather than precisely right. And approximately right at scale is just a slower path to context rot. Vectors tell you what's similar, they cannot tell you what's related. And those are fundamentally different questions. Similarly means these tool descriptions use similar language, and these capabilities overlap conceptually. Relatedness yields this tool has authority over that task, or this tool depends on the output of that tool. This tool is relevant when these specific conditions are met. Your CRM MCP server and your project management MCP server might have similar vector embeddings because they both deal with customer-related data, but one has authority over the customer records and the other doesn't. Vectors can encode that distinction at scale. They see proximity where there should be hierarchy. So you have two kinds of flatness at play. Structural flatness, vectors encode no relationship, no authority, no hierarchy between the things they represent. And mathematical flatness, high dimensional degrades the distance matrix that's supposed to compensate for that structural absence. The result is a retrieval system that becomes less decisive as your ecosystem grows. More tools, more embeddings, more dimensions, and progressively less ability to say with confidence which tools your AI actually needs right now. You can't buy your way out of the context rot with better embeddings. The architecture of similarity-based retrieval has a ceiling, and every MCP server you add pushes you closer to it. So let me bring this to a close. The MCP era is upon us. The gold rush is justified. The model context protocol is the most important infrastructure shift in AI connectivity we've seen. And it's not slowing down. But every MCP server you add loads tool descriptions into your context window. That's the tool count problem. The protocol's surface area is larger than what vendors are currently implementing, which means your exposure is growing whether you like it or not. That's the structural bomb. Your best engineers will accelerate this because that's what good engineers do, and you need them to. That's the human problem. The result is context rot, silent degradation of your AI's ability to assign meaning and choose appropriate actions. And a better search, a better embedding, a better retrieval can't solve it because vectors tell you what's similar, not what's related. So what do? You build better architectures using context graphs rather than vector embeddings. Graphs encode the things vectors can't. Which tool has authority over which domain? Which servers depend on each other? Which primitives are relevant to which task under which conditions? When your AI needs to select tools, the graph doesn't ask what's closer. It asks what belongs here. That's a fundamentally different question, and it produces fundamentally better results. Precise tool selection instead of an approximate retrieval. 3 documents instead of a filing cabinet. Middle market CEO should see this as a missing link. It will allow you to capture institutional knowledge to improve your positioning. Sticking with vector embeddings will save some tokens, but misses the plot. We save tokens where we can, however, we fixate on creating enduring advantage.